Hello and welcome to the demo of the Rosetta data translation tool. This demo is focused on transforming data from the ACADIS gateway. In order to reach this tool for actual translation, you will need to log into your ACADIS account and follow the links to the Rosetta data translation tool found under the Edit Metadata option in the gateway. When you follow this link, you will be taken to the Rosetta homepage. In this case, the URL, if you type in create ACADIS, you will be taken to a sandbox mode, which uses a demonstration file to help you navigate through the interface and learn how Rosetta works. There is only one data set in the project inventory, but if you're coming from your own project, you will see a list of the files available for conversion. There's also an option to restore metadata from a template file, which you produce the first time you go through Rosetta. In this case, the template file is available. We will continue this tutorial after restoring the metadata from a template. To proceed, you simply select Convert Selected File, and then the Next button will become active. At this point, you're allowed to select what kind of observation platform you would like to transform the data from. We're dealing with borehole temperature data, and therefore we will select single station or tower. The next step is going to be selecting the header lines of your data file. Since we're in the sandbox, this has already been done, but basically you want to select individual rows that make up your header. If you hold down the Shift key, you are able to select multiple rows. The next step is specifying the delimiter of the data you've uploaded. So we select comma, continue on to the next screen. Now we get to select the metadata for our data variables. The first column of data is actually year, but because we have time, in this case seconds since 1970, January 1st, we actually don't need the year. So if you click on the header row of this table, you get a choice between assigning a variable name and do not use. We're simply not going to use this. The first time you attach metadata to a variable, you get to assign a variable name. As you start typing, a list of potential variable names will come up. These are taken from the standard names list from the Climate and Forecast 1.6 specification. And the next question is this variable a coordinate variable? Examples are latitude, longitude, time, altitude. For time, yes. First, it will ask what type of coordinate variable you are dealing with. From the drop-down list, you may select from a range of different variables. In this case, we are dealing with time, and it's a relative time. It's the number of seconds since 1970, 0101. You also get to specify what kind of data you're dealing with. Is it an integer, is it a decimal number, or is it simple text? In this case, it's an integer. You're also prompted to record a description of your variable. In this case, we have chosen time recorded by the datalogger. And the units. The units actually aren't seconds, so let's fix this. We can use the unit builder to do so. We click Show Unit Builder, and then it will ask us what kind of units are we building. In this case, it's a relative date time. It's a time since some beginning date. And seconds since 1970, 0101 is in fact what we want to do. And we will add the unit. You can also give it a CF, the Climate and Forecast standard name, if you wish. But if you choose from the pre-populated variable names, that will automatically be filled for you. When you're done editing and adding variable attributes, simply click Done, and you will be taken back. Now let's move on to our next variable. As you can see, the pieces of metadata required and the recommended metadata are different for this data variable. And this has to do with what we've selected in terms of, is this variable a coordinate variable? In this case, no, it's not. And we're dealing with soil temperature, so that's a floating point number or a decimal number. The metadata for a non-coordinate variable is much more extensive than a coordinate variable. So we have an instrument description, we have the missing data value, we have a variable description, and then the units. Now in this case we're in degrees Celsius. Note that this is degree_Celsius and not capital C. For CF conventions, capital C would be coulombs, which is not what we're measuring with a soil temperature probe. When in doubt, use the unit builder. If we enable the unit builder and select temperature, we can see there are just a few choices. Under the recommended metadata, we have things like instrument height, the unit of the instrument height, the maximum calibrated value, the minimum calibrated value, as well as the CF name. From here, you may enter metadata for other columns of data as well. The next step is specifying site-specific information. This includes station or platform name, altitude, longitude, latitude, and the units associated with those. Once these are entered, you may go on to specify general information about your dataset, such as title, description of the dataset, among other pieces of metadata. Finally, once all this information has been specified, you can download the converted file. In this case, we have a netCDF file being returned that is compliant with CF 1.6. Also returned is something called a template. Rather than re-enter all the metadata that was previously entered in the Rosetta interface, you can restore your template file to pre-populate all of the attributes. This reduces the time required to convert datasets when they are simply updates of previous data. Finally, if you come to Rosetta through the ACADIS gateway, you will be able to upload your converted dataset directly to your project in ACADIS. Since we are in sandbox mode, we will not have this option. This is the end of the Rosetta demonstration. If you have questions, feel free to contact ACADIS support at support@aoncadis.org. Thank you.